Okay, so calculate the expected value for rolling a standard six-sided dice, numbered 1 through 6. You win $190 if you roll an even. You win $650 if you roll the number 5. Now, what are we even talking about? This is brand new concept. Let me go with you to the notes. So if you go to the notes and for the exam 4 notes, let me get those for you. And so the exam 4 notes, you come on down. There we have it. It's right on this page, expected value. Let me grab that and paste it in here for you. There it is. Okay, so expected value. What is this? This is in the notes. So by the way, I just added this part about the fish. We'll get to that later. So if you want to get a new copy, I just did it minutes ago. So expected value. The expected value is the average amount of money you will win, positive value, or lose, negative value, each time you play the game. It tells you what to expect will happen on average. So the expected value is probability 1 times value 1 plus probability 2 times value 2 plus probability 3 times value 3, etc. Multiply each probability by each value, add them up. A fair game is when the cost to play equals the expected value. All right, so let's get back to what are we talking about? Well, on this problem, you are rolling a die, and you can get the numbers 1 through 6, right? You win 190 if you get an even number, and 650, at least those are my numbers, if you roll the number 5. So how does that work then? Expected value. Let's write it out here. Expected value. What it equals. So first I've got to do the probability. So I'll do the probability of, what's the first thing? Even. Getting an even number. Even. Times $190. Because that's the value. Plus, and then it's the probability, what comes next? Oh, roll 5, probability of getting a 5, times, and what's the money for that? $650. So that's what we need to figure out. So what's the probability of rolling an even number? Remember, we have the numbers 1 through 6. So how many are even? 2, 4, and 6, right? So the even numbers are 2, 4, and 6. So it's 3 out of 6. So the probability of getting an even number is 3 out of 6, isn't it? Are you with me so far? Is this making sense? So we're rolling the die, the six-sided die. We want to get an even number. What's the probability we're going to get an even number? Well, it's 3 out of 6 because it's 3 numbers, 2, 4, 6 out of 6. 3 out of 6 times the 190. And then plus, now what's the probability that we're going to roll a 5? Well, that's just 1 out of 6, right? 5 is just 1 out of the 6 different numbers that can happen, times the money that we get if we roll that, $650. And so now we just hit the buttons on our calculator. Let me write out exactly what buttons we hit. So we're going to go 3 divided by 6 times 190 plus 1, right? Fraction means divide. 1 divided by 6 times 650. Just like that. And then hit equals. And I'm getting 203.33. Just round to the nearest penny. This is money, right? So the expected value is $203.33. That's the expected value. And what is that? What is that number? That's the average amount of money that you expect to win when you play this game. So what am I talking about? Well, that means on average, every time you play this game, you can expect to win $203.33. Now you might think, well, there's no way you're going to win that. You're going to either win $190 for my numbers. You're going to win $190 if you roll even, or you're going to win $650 if you roll a 5, right? Or you're going to win nothing if you roll a 1 or a 3, right? 1 and 3 pays nothing because it's not even and it's not a 5. So you might win nothing. You might win 190. You might win 650. The 203 is what you're going to win on average. That's the average. That's the expected value. It's what you expect to happen on average. Sometimes you win 190. Sometimes you win 650. Sometimes you win nothing. What's going to happen on average? Like if you do this hundreds and hundreds of times, what's going to happen on average? It's going to be like you're winning $203.33 every time. That's the average thing that will happen. We call that the expected value. It's the average value. It's what's going to happen on average. It's what we expect to happen typically. All right, now, in order for this game to be considered fair, now what's a fair game? Well, if you go to the notes again, a fair game is a game in which the cost to play equals the expected value. That makes sense. The game is fair if they charge exactly what you expect to win on average. Right? So, in order for this game to be considered fair, you would have to pay exactly the same as the expected value. That's the option we choose. And the next one says, the definition of a fair game is when you pay, and this is going to be, what is the exact word they use there? I don't remember precisely. They use the same amount as, okay. The same amount as. The same amount as the expected value. So that's a fair game when you pay to play the game and it's the same amount as what you expect to win. And then the final question, you should want to play this game. You should want to play this game if the expected value is more than the cost to play, or what you pay to play. Does that make sense? So when you have a random game, so this is exactly the calculation the casinos do. So the casinos, they calculate the expected value for each game. You know, the card, the blackjack, the dice, the slot machines, all of them, they calculate the expected value, the average amount of money a player is going to win, right? Sometimes you don't win anything. Sometimes you win a lot, a little. There's an average. That's what expected value is. It's the expected average amount you're going to win per roll of the die, per hand of the cards or pull of the slot machines, the average amount. And so what they do then is they charge just a little bit more than you're going to make on average. That way they make sure they're making money. The casinos have it down to a science. It's very precise for them. So that so a game's fair, and no games at the casino are fair, not a single one. It would only be fair if they charged you the same amount as you expect to win. And you should only want to play a game if the expected value is more than the cost to play. And that's no games at the casino. They have it all worked out as a science. That's why they always make money. And it's silly to think you're going to make money at the casino. You're just deceived. I know we all have uncles and aunts probably that say they make money, but they make money for a little while. But in the long run, nobody beats the casino. The only way to beat them is to cheat, counting cards, but they don't allow that. They watch for that. So there's no way. They have it all figured out. They have it calculated. So there we go. That's what expected value is. And a fair game is when the expected value is the same. And you should only want to play a game if the expected value is more than the cost to play the game. There we go.